Well, hello, welcome back. In this chapter, we are going to be continuing a little bit of a discussion we started in chapter 2. In that chapter, if you remember, we talked about 3 common states of matter, which is gases, liquids, and solids. And so in this chapter, we're going to focus a little bit more on the gaseous state. And we'll also apply the chemical calculation skills we learned in the last chapter, chapter 3. So things like dimensional analysis, unit conversions, things of that nature. So if you find that you need to go back and review some of those videos or review the homework for chapter 3, that's okay. That's definitely expected. In fact, the problem sets that are selected for this chapter, a lot of what you will do will rely on the things that you learned in the last chapter, in chapter 3. So it's always good to go back and to review those things before moving on. So, like I said, in this chapter, we're talking about the properties of gases. And our goal for this section, really in the whole chapter we're talking about gases, in this section we're talking about the properties of gases, is we want to describe the 5 macroscopic characteristics of gases. Okay, so what do I mean by that? Well, let's just go through them, okay? And then we'll see at the end of this video and kind of put it all together, what I'm talking about here. So the first one, a lot of these might seem very obvious to you, and that's a good thing if they do. So the first is that gases may be compressed. Okay, a fixed quantity of a gas may be made to occupy a smaller volume by applying pressure. Okay, so in this case we have some gas here, gas molecules. This is a macroscopic picture. And as always, if you've been watching these videos, my struggles with the pen continues. Okay, let's just try this one more time. We'll just abort and we'll try again. There we go. Okay, so there's a gas in there, and I suppose these are weights maybe that they're putting on here. So 2 weights, and then they put 3, and the gas gets compressed more. They take some weight off, you know, there's less compression, or they lift the thing. Okay, so that's again one of the characteristics or properties of a gas. Gases can be compressed to occupy a smaller volume by applying pressure. All right, the second property of a gas is that gases expand to fill their container's volume and to fill it uniformly, okay? So that's the key. So no matter the position of the piston here, the gas fills that space. And remember in chapter 1 when we talked about representations of matter, or maybe that was chapter 2, I don't know. But I said chemists look at macroscopic things and they view them through a particulate level view. So this is a particulate level view of what you're seeing on the top here in the macroscopic view. So each one of these little spheres is a gas molecule. And as we see, as the volume of this container changes, these 5 gas molecules that are in here uniformly fill the container. There's not all the gas molecules in the lower left-hand part of the container. All the gas molecules didn't zip to the top of the container and stay there. They uniformly fill the container. Okay, so that's a property of gases. So another property of gases is that all gases have low density. So for example here, the density of gaseous air, right, shown here, this is air, and this balloon is less dense than liquid water, okay? And of course, that's less dense than solid iron. So this is like an iron nail kind of in the bottom of this container here, illustrating the differences in density between these different states of matter. So again, gases have a low density. That's one of their properties. And so the balloon is kind of sitting on top of the water in this example. Okay, so fourth one, we're almost through all 5. Gases may be mixed. So you can add a gas to a gas that already occupies a rigid container of a fixed volume. So I don't know if you could see this, but this is one type of gas over here on the left. And on the right, it's a different color. It's a little hard to see on my screen actually, but these guys are all like red, let's say, and these guys are all blue, okay? So they're different types of gases. You can mix them in a container of a fixed volume, okay? It doesn't matter, it doesn't really change anything. And we'll talk about that a little bit more as we go through the properties of gases and the ideal gas model. So, but for this, like I said, the property of gas is that they may be mixed. So you can add gas to a gas of an already occupying a rigid container. All right. So finally, this video isn't very long, and this whole chapter really isn't that long compared to chapter 3. But the fifth property of a gas is a confined gas exerts constant pressure on the walls of its container uniformly in all directions. Okay, so there's that idea again, this uniformity. So there's this is a unique property of gas, independent of the external forces such as gravitational forces. What do I mean by that? Well, hopefully this makes sense, kind of this diagram here that's also found in your textbook. But let's say we had a container basically like this guy, okay? And the one on the left is filled with a gas and the one on the right is filled with a liquid. And these guys here, all right, so let me just erase that so I can keep drawing on this picture. These are pressure gauges, okay? And so for the gas, the pressure in this container is the same, okay? At the top of the container, at the bottom of the container, at the sides of the container, okay? Whereas for a liquid, what this is trying to illustrate here is if I had a liquid in some container, perhaps the same container that the gas is in, the pressure may not be uniform. Okay, and that's what this is showing here, that these are pressure gauges showing that the pressure may not be uniform for the liquid sample. Maybe an example, you have more liquid at the bottom of the container than you do at the top of the container. All of these things kind of come into play. All right, so those are the 5 properties of gases. And in the next short video, we're going to be talking about the ideal gas model.